Everyone. Welcome back to our YouTube channel. This is group 4, the Med Connect AI. I'm Shiraba Madrin, together with my colleague Edward. We're going to be taking you through our business pitch for our work, Med Connect AI, as I had mentioned earlier on. And these are details and credentials. So basically, the problem statement of our work is that the cancer outpatients often find themselves in scenarios whereby they have limited access to reliable, up-to-date medical guidance. And in most cases, they need medical guidance on how to manage their symptoms, how to engage in their treatment, how to manage their side effects, but then they don't have the access, the unlimited access to this medical guidance. Some of this could be where they are situated physically, maybe money, they don't have money to pay for consultation. So in Uganda, this is actually a visual representation of the global cancer treatment access and delays. The pink one is in Uganda, this is India and USA. But basically for our work, we are focusing on Uganda, and it's only 15%. This is the global treatment cancer, 15% in Uganda. And these are some of the reasons for emergency cancer visits. There is so much pain, there are side effects, there are infections, and maybe other effects like pain, anxiety, stress, all that. So basically, the objectives of our work is to come up with a conversational AI system that generates the personalized medical guidance to these cancer outpatients, and also enhance patient-provider interaction through the intelligent recommendations, because it doesn't mean that there won't be the medical personnel or providers behind the system, because we need a validation from the oncologists, the doctors, and all that. So by doing that, we're going to be able to enhance the patient's provider interaction, and then also improving data accessibility and decision-making efficiency in such a way that if someone gets the information, they get to know what they're supposed to do depending on the information they've received. So in such a way, decision-making efficient. In such a way, decision-making is improved. So this is our solution overview, whereby it starts with the user query input. And then when the user inputs their query, the query is classified. And then after that, it goes on to the graph retrieval augmented mechanism, whereby it picks the result, it picks the data or the context from the knowledge graphs. And then it picks the medical knowledge from the knowledge graphs, and then it goes to the fine-tuned conversational AI model that generates the personalized responses. And then after this response is generated, we go ahead to check for its confidence. We go and check for its confidence level. If it's high confidence, then we go ahead and deliver a response to the patient. But then if it's low confidence, we then have a clinician review of that response. And then if it's verified, the model goes ahead to deliver the response to the patient. Then the patient, then the patient gives feedback and also learns. Then if the patient gives feedback, the model is able to refine and update the knowledge graph. In doing so, the accuracy keeps on improving, and also the responses are of high quality or confidence. So for the data, we created our own corpus from the clinical trials, and we basically focused on phase 1 to phase 3 cancer treatment trials. And this included the metadata and the unstructured text, which included trial summaries. Then we had to get this data, to process it, and then we do the text cleaning, we did the tokenization, and also the lammentization. So the TF identification was used for the feature extraction to highlight the key terms, and this corpus supports the AI models to generate the personalized insights for the cancer patients. So these are some of the outputs we're able to get from our data. This is from the clinical trial summaries, and this is for the percentage of missing data per column. Yeah, and this is actually a continuation of the results that we got from the data that we used. This is the distribution of the clinical trials, and this is phase 2, phase 1, phase 3. This is for the clinical phase, and this is for the enrollment site distribution by the clinical trial phase. That was it from me. Thank you so much. My colleague will take it from there.
Good afternoon. My name is Guy Edward. Now continue from where my group mates stopped. I'll start with the models and techniques we used, and we used transformer-based models from Hugging Face with graph enhanced retrieval to implement knowledge graphs. We also use GP2 to train our model, and the reason we chose that is because it is computationally more efficient for our project. Next, I'll talk about the system architecture, which starts with an interface, where a user is able to input a query, and deep down the system, we shall have the query processing, which is enhanced by the knowledge graph-based retrieval, whereby these knowledge graphs are built using graph embeddings and price index. And then the fine-tuning is also carried out with the help of backend database and API integration. And at the end of it all, the user is able to receive a response in the context in which they asked. Next, I'll talk about the implementation details, which involved the language we used, which was Python. Then we use libraries such as TensorFlow, PyTorch, and Hugging Face transformers. And then we were working on Google Colab as our platform. Then our next slide talks about the metrics used to determine the efficiency of our model and also to evaluate our model. These evaluations were generated with the help of weights and biases. And we concentrated on metrics such as the accuracy, precision, recall, and F1 score. And from the visualizations or the graphs, we see that we achieved a precision of about 78. And then our Abdo score, which is very low, and one of the important aspects of our large language model, it is as below zero, as is below 0.1. And then our perplexity score, which is also very low, and other visualizations as you see them. Next, our impact and relevance to Uganda is that we enhance cancer patient care in research settings, given the fact that our country is poor in terms of finances. So our model helps to support cancer patients, our patients that are compromised because of their financial status. Then globally, we want to contribute to AI-driven healthcare advancements. And the SDGs are good health and well-being, which is the third, then industrial innovation and infrastructure, which is the ninth. Next, I'll talk about the intellectual property and innovation. Our novel system combines conversational AI, graph database, and retrieval augmented fine-tuning for our patient cancer management. It is a unique integration of contextual cancer data retrieval, which is good from clinical trials. And the benefit is that we improve patients' access to personalized information and reduce burden to the health personnel with the growing rise of patients and who want to inquire about their diagnosis. Next, we have a quantitative algorithm and cooperative software, and we focus on optimizing information delivery to cancer outpatients. I'll talk about monetization and scaling, where so when we talk about the market size, we are an expanding telemedicine and AI-assisted diagnostics team. And our competitor analysis, given the fact that idea is a novel idea, we only have limited AI-driven conversational agents in oncology. Next is a demo that I'm going to play of how our model works. and which is not well developed given okay, that was the demonstration of our chatbot. Okay, our contributions as a group, personally, I contributed in developing and fine-tuning the model, optimizing and hyperparameter tuning, then the evaluation and improvement. Then my group mate, Madrid, was responsible for data collection, cleaning and pre-processing, feature engineering and selection, then data analysis and visualizations. The lessons learned from the challenges, the lesson learned is we need a knowledge graph so that we improve on the information that is provided by our model. And this is learned from challenges of data quality, model interpretability, and deployment issues. Our future work is to enhance our model adaptability to real-time changes in the health sector and personalization. Then we plan on expanding the dataset diversity for better generalization, then also integrating with hospital systems such that this AI is used in hospitals. And I would want to conclude by stating that our project demonstrates the potential of conversational AI in outpatient cancer management, which enhances efficiency, patient engagement through graph retrieval, augmented fine-tuning. Thank you for listening to me.